We begin by substituting the values of a, b, and c into the quadratic formula. Here they are. Our b's substituted in, our a's, and our c. So x equals negative 4 plus or minus 16 minus 24 divided by 4. Negative 4 plus or minus the square root of negative 8 divided by 4. This is a problem. We cannot perform the square root of a negative number. No two numbers can be multiplied together, or no number can be multiplied by itself to give us a negative number. Therefore, this quadratic relation does not have any real roots. We'll come to this conclusion any time where the square root is a negative number. We can't take the square root of a negative number, so the formula cannot be evaluated any further. Let's consolidate or review what we have discovered. Here's the quadratic formula. What we need to pay attention to is what's underneath this square root. B squared minus 4ac. If b squared minus 4ac is bigger than 0, or is a positive number, then the quadratic relation has two real roots. If b squared minus 4ac is equal to 0, the quadratic relation has one real root. Lastly, if b squared minus 4ac is smaller than 0, or is a negative number, the quadratic relation has no real roots. So in this situation, there are two x-intercepts, or two real roots. In this one, it will have one real root, or one x-intercept. And for this one, it will have no real roots, or no x-intercepts. Here's an example. So if the square root of 25, this is a positive number, you'll have two real roots. For this one, there will only be one real root because the square root is 0, or the square root of 0 will be 0. And in this one, we cannot go on any further because it's a negative number, and we cannot calculate the square roots of negative numbers. So there is no real root. Always pay close attention when using the quadratic formula to these values.